how's everybody going? I'm sorry I'm the last speaker between you and well-deserved beers, so I'll try to be as quick as possible. And so this title is not very meaningful, probably, but I'm sure that whenever we start a new software project, we all felt that embarrassment of picking up the different pieces upon which we will build our things. So what I'm going to talk to you about in this talk is not just a list of ingredients. Sorry, I should probably take this out. I'm not going to talk about a list of ingredients, but what I'm gonna say is more like what is my personal experience and how do I struggle like this? Cheers. How, in my personal experience, in my work experience, I made those choices. What I'm not going to provide here is a catch-all solution. So I'm not going to give you the right recipe to build your next web app or microservice or whatever you want to build. So that said, let me just briefly introduce myself. I'm a Python user since about 2009. I'm a physicist by study, but I work now for a company, and I'm a scientific software developer since 2020 when I left academia. And whenever I'm not doing software, I do hardware. So that's me doing hardware. Let me also briefly talk about my employer. ExactLab is a small enterprise based in Trieste. It's a spin-off of SISA, a well-known university there. And we mostly have a scientific background, and we try to bring that expertise into the IT world. And small advertisement, we are hiring a sysadmin. So if you are in the market for that, please let me know. So this is precisely what I was talking about, right? We are starting a new project, and we find ourselves with so many ingredients in our hands, and we don't know what to start. Do I start by the flour, the tomato sauce? What do I start with? And I'm sure everybody can pinpoint a moment in their career where we have two different products, two different technologies that we could build our product on, and we spent days and days and days trying to assess which of the two or which of the many is better. And let me also quote the Zen of Python: there should be one and preferably only one obvious way to do it. And we perfectly know that this never happens in our day-to-day experience. And so, and here Santino almost spoiled my talk, the key to a good choice is to ask, first of all, the right questions. And I have three categories of questions. So the first ones are the good questions. What are the functional requirements of the thing that I need to build? What is the state of the art in the market? So what are the technologies that are considered top-notch in that field? How maybe that's not the first time that this problem or a similar problem gets solved. So how others approach that problem. And there are the bad questions, which is given all the above, how well supported is that technology? So do we have a wonderful library, but which completely lacks support? Is the library maintained or a technology maintained? How is the documentation? Let's remember that we need to write software and write it proactively and efficiently. So documentation, even the best possible library or technology from the technological point of view, will be of very little use to us if we do not have thorough documentation. And then, of course, there are the ugly questions, which, computers are kind of dumb. They always do what we tell them to do. So the human factor becomes very relevant in this problem. And so often the key problem in a new project is trying to extort information from our customer and have him or her define precisely what they want. And often that only comes very later in the development project. And so you know, from X files to quadlib, no? So if you have bad propositions, bad requirements, then what you can build on top of that, even with the best technologies, will not be exactly what we wanted to build. That said, we need to build a web app, right? So we need to select the ingredients that compose our web app. And I made this little pyramid, most of all because that's what you know, Google Slides provides, so that was very handy, but also because that's how the web app, any web service is really based on, right? You have the foundations. You need to have very solid foundations. So you need to make a good choice of the base layer framework. And on top of that, you need to start to make incremental additions that compose the whole application. So you'll have to get into data persistence. How do you persist your data? How do you build authorization and security on top of that? How do you build your web API if you need one? How do you build a front end on top of that? So from the ground up, we need to make these choices, and all the choices below will directly inform and change the choices that come above. So let's start from the ground. And regarding frameworks, we know that we have, on one hand, micro frameworks where all the choices are upon us. We basically have an empty canvas and minimal structure where we can add all the ingredients we want. And they're characterized by a very simple core, very little code to achieve a minimal result, a minimal valuable result. And then on the other hand, we have other frameworks that are more high level and that kind of catch a wider set of problems where there are kind of standardized solutions, no? And in that case, high-level frameworks like Django, for instance, takes educated stances on some infrastructural choices, like, for instance, providing us already with an object relational mapper, or suggesting a database rather than another. So in that case, in the case of high-level frameworks, we have a more complex core and usually also more boilerplate code to start with. Both of these solutions, so micro frameworks on one side and high-level frameworks on the other, rely on some plugins to add additional functionality. So that's something that does not, neither micro frameworks nor high-level frameworks will preclude us from adding whatever components we want on top of it. Just, I mean, the way in which we integrate further components will depend, of course, on the foundation that we put on below. So in my talk, I'm gonna focus on just micro frameworks. That's not to say that I don't like Django. It's just that I don't have enough experience on it to give a talk on it. And because Flask and FastAPI have been the core foundation of projects that I've been involved in the last couple of years. So FastAPI and Flask are pretty similar from the philosophical point of view. They're extremely minimalistic, both of them. The main differences are that Flask is much older, and I don't know if everybody knows, but Flask started as an April Fool's joke. So the first release was actually in April Fool's of 2010, whereas FastAPI is a much more recent project. And whereas one is based completely on a synchronous routing system, the other one, FastAPI, is based on an asynchronous routing system. And as for the differences and similarities, both allow to provide HTML to provide HTML endpoints, and whereas Flask has got a templating engine built in, FastAPI allows to plug in the same Jinja 2 templating engine, but it's not built in the core micro framework. In Flask, there's no default Auth or security, whereas in FastAPI there is some boilerplate that you can use to build on top. In Flask, there's no automatic documentation of the endpoints, whereas in FastAPI there is. In Flask, there is built-in logging, whereas in FastAPI you have to implement it yourself. So, as we saw here, like there's a spectrum. It's not that there is something that is bare bones and you need to build on top and something that gives you everything. There's a spectrum of some components that are provided with you with the framework and some others that you need to add later on. So what are my personal takes on these two products? What do I miss the most? And what informs me on choosing one or the other? When I use Flask, the things that I miss the most of FastAPI are for sure, first of all, FastAPI's automatic OpenAPI documentation. FastAPI's use of Pydantic everywhere to have a safe type system. FastAPI built-in authorization. And the fact that FastAPI, being a more recent framework, has leveraged on the nice goodies of latest versions of Python. On the other hand, when I use FastAPI, I do miss some features of Flask. For sure, first of all, undoubtedly, the Flask reference documentation. Flask is a thoroughly documented project, and it's got lots and lots of documentation tutorials that you can find. The other thing is the fact that Flask exposes some proxy objects that are local either to the same request or to the same session, and this is missing in FastAPI, where there's a dependency injection system used, and of course the Jinja 2 templates. So let's move on. Let's move up one step on the pyramid, and let's talk about how we persist data. When we persist data, we have two main paradigms to follow, either block storage or object storage. Both have pros and cons. The pro of block storage is for sure that it's very simple. We just have a folder in our file system where we toss files in. Object storage, on the other hand, has got leverages on some external service, so we need to be able to talk to this external service in a way for our application to store data there. Of course, there are also some penalties to pay. In the case of block storage, the main one is that you must take care of backups. On the object storage, of course, there's the complexity to talk with an external service. So this is just to give you an idea of how simple it can be to store a file using Flask on block storage, so on a path on the file system, and this is how you achieve the same thing in FastAPI. Whereas if you use object storage, you really need to, first of all, from the infrastructure point of view, think about where you're going to store your data. You can either use a public cloud service, or you have to implement or set up a service on your local premises with tools such as Minio or Ceph that both provide an S3 interface. And of course, you need to make your application talk to these services, for instance, with the Boto3 library. Boto3 is the de facto standard in Python to talk to Amazon S3 protocol and to all the S3 compatible services. I'd say it's very complete, but also it's very, very vast. So the first approach to this library can be a bit daunting if you have no prior experience with it. And this is just a snippet to show how you can achieve those same, let me just rewind back to this snippet. So this is how you store a file in the file system using FastAPI. So very, very little code. And this is the equivalent code to store it on object storage. So as you see, you have to take care of credentials to log in and authorize with the with remote service. You need to initialize the Boto3 client, and from there you can request the objects. So this is the easiest way to achieve the same thing. Then, of course, once you have persistence, for static files, you might need a database. So how do you do databases? Well, there are plenty of choices. There are two big families, of course. One is SQL, one is NoSql. And the choice between these two are mostly due to how you model your data and the problem you have at hand. So depending on the actual problem, you have pros and cons. However, what I found, and I suffer for it, is that even though a problem was, let's say, prototypically, archetypally, the right problem to be mapped on a relational database, so in a SQL database, we found that the customer's inability to well define the problem that we wanted us to solve kind of made us lean toward a NoSql database. And that's because the requirements change so often that keeping up with the strict schema of a SQL database became quickly unmanageable. From the Python standpoint, using SQL versus NoSql, of course, comes also with the choice of how you connect to these databases. So for SQL being more, let's say, an older technology or a more proven technology, we have plenty of choices. So we have all sorts of Python ORM, both sync, kind of like the standard that is Sqlalchemy, and async, like Tortoise, that is extremely fast for if you need to ingest lots and lots of data into SQL database asynchronously. And especially in Flask, we have the excellent Flask Sqlalchemy library that allows us to talk in a very native way to a SQL database. And let me also mention Flask Migrate by Miguel Greenberg, which is an excellent tool to handle migrations in a Flask project. For what concerns instead MongoDB or NoSql databases in general, I have experience with PyMongo for what concerns synchronously talking to a MongoDB database, and in FastAPI there is Motor, which is an asynchronous interface based on top of PyMongo. I'd say that the support and the documentation is good. It's what I find a bit daunting whenever I have a problem with Motor is the fact that the way in which it's written is very, I find a bit cryptical because it's kind of like meta-programming on top of several async framework. But this is just my personal opinion. I don't want to say I'm 100% grateful that those libraries exist. Another problem that you often have is data serialization or deserialization. So how do you feed in or push out data out of your application? And even here you have plenty of choices. I have experience with two of them. One is Marshmallow and the other is Pydantic. And they take a very different approach to this problem. So Marshmallow is a very mature library. It's been around for years. It's very well documented. And the key feature that I like about Marshmallow is that it's easy to write similar models. Think about the typical CRUD problem, right? Where you have to create a model, you have to update a model, and you have to show the model. So typically you have three models where there are more or less the same fields, except for the create doesn't have an ID because the database will fill in that field for you. The update, you might not want to update the ID or have some properties that are read-only. And then in the show, you might have some business logic that modifies the model before showing it to the front end or to the consumer. So in Marshmallow, it's really easy to change, for instance, whether a field is, so a field, I mean an attribute of these classes, because of course everything is mapped in a class. It's very easy to decide whether a field needs to be mandatory or not, whereas instead Pydantic, it's a very new project. It's got a huge community traction. It's the standard of FastAPI, so if you're using FastAPI, chances are you use Pydantic too, and uses data classes. So it leverages on the latest technologies given by the Python standard library. On the other hand, I find a bit tedious to create that same hierarchy of related classes. So whereas with Marshmallow, I can create a single class and then modify slightly the fields that I want to show on a case-by-case basis. With Pydantic, I often find myself having to duplicate or inherit from a base class and then add several more fields. And if you put into this equation also MyPy to check the typing, it becomes very quickly a mess, because maybe you wanted to change the type of a field between the update and the show model, and it becomes really a mess really quickly. Like, there's a dramatic proliferation of classes. So now we have data persistence, we have a database. The first thing that we want to do, and it's the first thing that we want to do, let's not drag it on, it's that we want to implement Auth and security. And there are several ways to do this. The first one, and the simplest one, is to create it custom. So we have a table users in our databases, and we write custom code to fill in those, to fill in the users, fill in their hashed passwords, and let it be hashed, and all the other information we want. And of course, both in Flask and in FastAPI, you can achieve that very easily with an honorable mention for Flask, in which you have a very wide variety of plugins that are ready for you to not have to reinvent the wheel every single time. In FastAPI, on the other hand, we do not have this all of these nice plugins yet. I'm sure that there are going to be more complete solutions appearing as the community is very vibrant. But the thing that I like the most in FastAPI for what concerns Auth and security is that we have an educated choice made for us by FastAPI, by the framework, and that is the use of standards. I really like standards. I think everything should be interoperable in a well-designed web app. And so the fact that FastAPI makes it very easy to implement authorization directly with OAuth, I think is a very good point, and is a very good plus on the FastAPI side. Let me also mention that very often you are not building just one service, but you're building many services that need to interoperate. And in that case, it can be non-trivial to orchestrate all the authorization or authentication for all the services. In these cases, it might be worth it to rely on third parties, like the usual button logging with Google or logging with Facebook, or even to implement your own solution of single sign-on, like for instance with Keycloak, which is a Java project by the Apache Foundation, I think, which is a good choice if you need to do this. So we are moving up this pyramid, and we are at the point that we need to start exposing our endpoints. And so exposing the endpoints is good. Documenting them is even better. And what I really like of FastAPI is that as soon as we publish an endpoint, it's documented. You don't need to do any extra work, it's there. And this is a very sour note on FastAPI, on Flask side. because I have not to this date found a solution that is as flexible and as simple to use. There's a plethora of plugins. There's Flask REST, RESTful, REST Plus, App Builder if you want a more comprehensive solution, which are all kind of like a fork of each other, and they build on one another, but they are not particularly flexible in my modest opinion. So yeah, this is, for instance, a simple endpoint that I created with FastAPI. I did not have to write any extra code to have a well-documented API like this. And we come to the front end, and this is probably the only point where the two frameworks are really equivalent. Minor that Flask has the templating engine built in, mostly because Flask and Jinja come from the same mothership, that is the Palette project. But both Flask and FastAPI are very easy to use together with Jinja 2 templating. So for once, we have a common language between these two frameworks, and it's really, really easy to send some HTML to our consumers. So this was very fast. My time is getting short. How do we make the choices? Well, you know, in the kitchen, you do not want somebody else to tell you how to mix your ingredients. So that's kind of the same thing. If in the lucky cases where you can choose, personal taste does matter. Of course, there are some bits of information that come into that decision that are not strictly technical. So to me, key ingredients are whether the project or the product that I'm using has a good ecosystem behind, whether there's good documentation, whether there's good learning material. And let me just have a very 1-second rant about the trend that I see in software development nowadays, where we substitute reference documentation with tutorials. I think this is detrimental, and we should really get back into writing good reference material. And lastly, boundary conditions that are out of our control also come into play when choosing the ingredients. So whether we have full control over the infrastructure, sometimes you have to deploy behind a VPN or in an infrastructure where you cannot install what you want, whether the customer mandates some components, and whether in your team there is a particular expertise that you want to leverage on. So bottom line is these are the ingredients, but then it's up to us to mix them in the right way. And with this, I thank you for your attention. I'm sorry that I was between you and the beers, and thank you.
Thank you. So we are spaced to one question, that is, what do you mean by somewhat tricky logging with FastAPI?
Tricky logging, okay.
Yes.
So whereas in Flask you have a built-in logging, so you can just import the logger and log directly into the same stream, let's say. In FastAPI, there's a somewhat, to me, I mean, maybe there's an obvious solution that I did not find yet, but to me there's a bit of a confusion. It's a bit confusing how you write in the right log. So if you try to do the same thing that you would do in Flask in FastAPI, what you end up is that you do not end up in the right log. You have one log that when you open your server, your test server, or your UVcorn run, blah blah blah, and that is not the same log where you write if you import logging. So there are two logs effectively. There's one log for FastAPI, and there's one log for the backend server for UVcorn. And getting your message through FastAPI and into UVcorn's log I did not find an obvious solution. So that's what I mean. If you know a way to easily achieve that, I'm very interested to know.
Okay, thank you.
Cheers.
Actually, so I'm a maintainer of Unicorn.
Okay.
On Flask, you not going to use that logger because on Flask you are not actually use that logger that you said because you probably are going to put in production with Unicorn or another US server, right? So it's kind of the same condition and the same that on access logs that you have on FastAPI. On Unicorn, FastAPI Unicorn, you have also the access logs, as you mentioned, which is equivalent to Unicorn when you're going to do with Flask in production.
Okay.
You also have, actually this is important, because the Unicorn loggers on the access log, they are very limiting on the information that you can put there. So there is a package, if someone wants, that's called ASCII logger that makes that easy.
Okay. Thanks a lot.
Okay, thank you.
If I may, let's thank the staff because this conference is amazing.